This is Geometry, Unit 3, Day 7. We're talking about some angle pair relationships. So here we're going to first discuss what a transversal is. It's a line that intersects two or more lines. So if you have a line and you have another line, this here would be called your transversal. We could label the transversal T. A lot of times it's called line T. You could have two other lines that the transversal goes through. Transversal intersects two lines or even more. So here, what we're noticing is that two angles are a certain name if they have similar positions relative to the points of intersection. Look at their location. They're both on top of the line, both to the same side of the transversal. So we would call that corresponding angles. Regardless of how they're in here, an angle here and an angle here, notice that they're on the same side of the transversal and they're both below the line. In this case, they're both above the line on the same side of the transversal. They're both pointing in the same general area. If you were to trace out these two angles, what shape does that make? Or what letter does that make? It makes an F shape. So that might be one way to help you identify that. Now, of course, this F is kind of upside down. Or it could be backwards if it was focusing on two angles out here. But the key part is that they're on the same side of the transversal. They're both above the line in this case, or they're both below the lines in this case. Here, notice you have your transversal, you have your two lines. They're both called interior angles because they're in between the two lines. If you squeeze those two lines together, they will get squished. But they're on alternate sides of the transversal. So these two angles are alternate interior. And if we were to trace them out, notice what would happen. What shape might you call that? What letter might you call that? Because it's so sharp, we might not call it an S, but a lot of times people consider this V shape. I'll also often call it zigzag. Notice that they have different vertices, so do these, different vertex. They're called alternate interior because they're on alternate sides of the transversal. Notice here we have our two lines. The two angles we're talking about are not inside those two lines. If you squeeze those two lines together, the angles would not get squished because they're on the outside. So they're called exterior angles. And because they're on opposite sides of the transversal, they're considered alternate. So the two angles are alternate exterior angles if they lie outside the two lines and are on opposite sides of the transversal. Some people make a mistake and call these vertical because they're pointing essentially in opposite directions. But notice, both of these have a different vertex. If you trace out the letters, if you trace out the angles, they don't make a letter. Not like the F shape did or the Z shape. Here we have two lines. If you squeeze them together, the two angles would get squished, so they're considered interior. And notice that they're on the same side of the transversal. So these are not alternate interior, but they're on the same side being interior. We're going to call those consecutive interior. And often, if we were to talk about two lines and a transversal and refer to these angles here, trace those angles out, what shape does that make? It has a C shape. But all depending on the direction of the two lines. Some people call it a U shape or an N shape, whatever. It's whatever helps you remember that that's a special type of angle. They're called consecutive interior. C goes with the C shape. So now we're going to look at this figure here, and we need to identify some of the following terms. Which of these terms is considered a transversal? Well, you could say that P is a transversal because it's crossing line Q and it's crossing line P. You could say that P is a transversal because it's crossing line Q and crossing line R. But line R is going to be our transversal in this case because that's the line the angles are around. It's crossing line Q and P, and it has the angles around it. So the transversal that we're interested in right now is line R. Where are some pairs of corresponding angles? So if you need to look back, those are the C shape. So if you would take your two lines and make a C shape out of that, kind of looks like an N maybe from this point of view. So angle 6 corresponding angles, not consecutive interior angles. Consecutive interior angles are the C shape. Those are going to be angle 6 and angle 7. Or up here you would have angle 2 or angle 3. Those are the two angles that are making some sort of a U shape. They're interior because they're inside the P and the Q. And they're on the same side of R. Corresponding angles, if you look back at your notes, made a mistake there, sorry. That's F. It's the F shape. So if you look here, you have this F shape running down your transversal and through the two other lines. So which of these angles would be considered on the same side of the transversal and on the same side of the lines? Below the P and below the Q. 5 and 7. On the same side of the transversal, to the right of the Q and to the right of the P. 6 and 8. On the same side of the transversal, up to the right of Q and to the right of P. On the same side of the transversal, to the left of the Q and to the left of the P. They're in corresponding positions. That means they're in the same type of position. At this vertex, we're talking about the upper left-hand corner. At this vertex, we're talking about the upper left-hand corner. Corresponding points. Or from the vertex, the upper right, 2 and 4. From the vertex, the lower right, 6 and 8. Those are different ways that can help you identify corresponding angles. Alternate interior angles. Alternate interior angles make a Z shape or a zigzag shape. So you have to come down one line, down the transversal, and down the other line, a zigzag. So 2 gets framed out, and so does 7. They're on opposite sides of the transversal. They're both interior, but they're not next to each other. They have a different vertex. They're non-adjacent. So the other zigzag shape, using the two interior angles, would be 6 and 3. Alternate exterior angles, they don't necessarily make a shape. They're not between our two lines, so they're not part of this interior. They're part of the outside, or exterior. This would also be exterior. So these angles are exterior. These ones are interior, inside. So if these are exterior, alternate exteriors, then we talk about angle 4 and angle 5. Angle 1 and angle 8. Okay, so next we're going to construct a pair of non-parallel lines constructed by a transversal. Trying to make them relatively straight. We're going to use a straight edge. So we'll make that our transversal, and then we'll make two other lines that are not parallel. Then we'll number these lines, these angles. Okay, we're going to use a piece of tracing paper and copy the angles that are formed. If we're going to look at the corresponding angles, that would be angles with the same vertex. I'm sorry, on the same side of the transversal without the same vertex. If you notice and you move it back and forth, they're not the same measure. If the lines are not parallel, then angle 2 is not congruent to angle 6. None of the corresponding angles are congruent to each other. If we look at the alternate interior angles, angle 2 and angle 7, if we were to switch this around, you would see that they weren't quite the same. Here it's going way over. So alternate interior angles. So angle 2 is not congruent to angle 7. If the lines aren't congruent, if the lines aren't parallel, the angles are not congruent. We're going to look at a pair of alternate exterior angles. If you were to bring this one around and line up the vertex, you see that this line comes through here, so the angle's way too big. 8 is much bigger than 1. So angle 1 is not congruent to angle 8. If the lines are not parallel, alternate exterior angles are not congruent. Consecutive interior. Consecutive interior angles, like 4 and 7, those two angles clearly are not congruent. And do they make a linear pair? Well, if we had 4 and 7, then that means I should be able to bring over my 7 and have a linear pair, but the linear pair would have to go here, so they don't even add up to 180. Angle 4, angle 7 are not a linear pair, not supplementary.